Hi, my name is Sean Candell and I will demonstrate PhotoSpread. The application is motivated by field biologists whose data contains images and associated metadata. PhotoSpread allows biologists to organize and analyze these images and combine the result with other associated data. The system enables the scientists to use the familiar spreadsheet paradigm during these tasks. The PhotoSpread user interface consists of two main areas. On the left is the traditional spreadsheet. Users can enter strings or formulas into cells as they would in other spreadsheets. Users can also load sets of images into cells. On the right is a workspace area. When a user clicks on a cell in the spreadsheet, the cell's contents are enlarged in the workspace. In addition, the workspace can be used to edit formulas, load images into cells, and tag photos. I have preceded cell A1 in the spreadsheet with 7 images that were taken in the Jasper Ridge Biological Reserve at Stanford University. Camera traps, set up throughout the preserve, capture photos of animals that break the installation's infrared light barrier. These installations also record data such as the temperature and humidity at the time each picture is taken. These measurements are added to each photo as metadata. Later, the biologists manually add additional data, such as the photographed animal species. When we scroll over an image, we can see the image's metadata. For now, we will organize photos that have already been tagged with metadata. Later, we will show various methods to edit and add new metadata to photos. We manually pre-assign animal species and age to these images. The species is either deer or bobcat, and the age is either adult or adolescent. We begin by setting up a 2x2 grid where we can organize the photos according to these attributes. In cells C2 and D2, we enter bobcat and deer for the 2 types of species. In cells B3 and B4, we enter adult and adolescent, representing the choices for age. In C3, we'll define a formula that will make all images containing adult deer appear in the cell. To do this, we click on cell C3 and enter the formula. This formula will return all the images from cell A1 with the species attribute equal to the value in the cell C2 and an age attribute equal to the value in the cell B3. The dollar signs have the same meaning as they do in other spreadsheet applications, such as Excel. After we enter the formula, 2 images appear in C3. These are images of adult bobcats, as expected. We can now copy this formula into cell C4 to see all the adolescent bobcats. Similarly, we copy the formula into D3 and D4. These operations collect adult and adolescent deer. With that, we have now organized our photos. Now suppose we suspect that an image has been tagged improperly. For example, in cell D3, an adolescent deer has been mislabeled as an adult. To fix this error, we simply drag the image from cell D3 into cell D4. The image now appears in D4, and moreover, the metadata of the image has been changed. We confirm this update by viewing the metadata in the workspace. In general, when a user drags an image into a cell that contains a formula, the image's metadata will be modified to satisfy the formula. The image remains unaffected if this behavior is not well defined. The last task in this example is to compare the average temperature when adult animals were captured with temperatures when adolescents roam through the camera traps. To automate this comparison, we define a new formula in cell E3. The expression C3:D3.temp returns the set of temperature values for the images in the cell range C3 to D3. We take the average of this set to get the average temperature for images of adults. We copy this formula into cell E4 to get the average temperature for adolescent images. Notice that the value in cell E3 is 44.3. That's awfully high and suggests that some images in either C3 or D3 must have inaccurate temperature readings. To track the suspected sensor malfunction down, we define in cell F3 a new formula. It will collect all images from C3 and D3 that purport to have been taken at a temperature greater than 40. We see that one image satisfies this formula. After right-clicking the photo, we can edit its metadata using the system's in-place editor. We change the temperature to a more reasonable approximation of 21. Notice that the image is no longer in F3 because it no longer satisfies the formula, and the average in E3 returns to a more reasonable temperature. In the next example, we will show another method for tagging images. We've already seen two ways to tag photos: the in-place editor and dragging images into a cell that contains a formula. Suppose now that we have images that we wish to organize into three groups. In cell C2, we place all the images of bobcats. In cell C3, all the images of deer. And in C4, all the images of coyote. We label the groups using cells B2, B3, and B4. The images themselves, though manually grouped together, have not actually been tagged. The species attribute is not defined for any of the images. We select cell C2 and all of the images in the workspace. Now we can drag the text bobcat from cell B2 onto the set of photos in the workspace. A pop-up window asks which attribute we would like to set equal to bobcat. Since we have not yet defined any attributes, we select New Attribute and click Submit. A second window lets us define the new attribute, so we type species and hit Submit. Scrolling over the selected images, we now see that all species attributes have been assigned the value bobcat. We repeat this process for the deer and coyote. Notice we do not need to redefine the species attribute.
Stepped out the tub and put my feet on the floor. I wrapped the towel around me and I opened the door. And then a splish splash, I jumped back in the bath. Well, how was I to know there was a party going on? There was a splishing and a splash.